Volatile memory refers to data that is currently being used or is being manipulated by the system or by the user. And it's stored in the random access memory, which is the RAM, and it gets wiped as soon as the computer gets restarted or turns off, rebooted, so on and so forth. And it is probably the most important source of data, especially when you're considering digital forensics, incident response, because of the fact that it's so easily wipeable. You can accidentally reboot the computer, or something may happen and the computer gets shut down, the power in the building goes, something may happen, and then you lose all of that data. So it is the first source of data that you want to make sure that you back up when you're doing digital forensics, and you want to make sure that you capture that image before you do anything else. And it's more important than most other sources of data when it comes down to digital forensics and incident response. And so this is what we're going to be talking about today, and this is a part of the analyzing volatile memory room that is inside of TryHackMe. This is a standalone room, and it's something that was a part of one of the other rooms that we did, a few of the other exercises that we did under digital forensics, and it's kind of an extension, an extra source of data, an extra source of learning that TryHackMe provided for us, and that's what we're going to be talking about in today's video. There are a handful of modules that are available, or a handful of tasks that are available inside of this room, and we're going to go through each one of these. I'll give you as much detailed information as I possibly can, but for the most part, we're going to be applying a lot of the concepts in this room to the virtual machine that has been assigned to us, and I've already started the machine, so I'm just going to go ahead and load that down, and we can see it on the right hand side here. It's a Windows machine because we're mostly going to be working with a Windows operating system today. And the first question that we have after we set up the lab connection is how many tools are present inside of the Easy Tools folder, which is this piece right here. And so once we load that, we should have a handful of tools here. And I think I can just select all of them and see how many are selected. And it says it right at the bottom right here. It says 12 items are selected. So I'm just going to drop in 12 and see if that's the right answer. And that is indeed the right answer. So that's what we got for our first official question inside of this room. So what we're going to do now is we're going to go into each one of these tasks and see what we're going to be working with and what type of data we're supposed to pull as we analyze volatile memory. All right, it's probably best to actually get the overview of what volatile memory actually is and how we can potentially manage that type of data. And Windows OS volatile memory mainly manages in the RAM, which is the random access memory, and it's also like this for Linux and Mac OS as well. And it does this to provide a better user experience so that you can quickly access certain types of data. Volatile memory can be currently used by the system or by the user, like the processes that are running, the services that are running, etc. And this is what it looks like. So if you open up the task manager, you'll see under processes where we have all of these various services or software that are currently running, and it shows you the type of memory or the amount of memory that's being used, the amount of the CPU that's being used by each one of these things. And you can find a few different types of key data. So they're running processes, obviously active network connections, meaning the open ports as well, thread information, execution states, and stack traces, system configurations, including settings, environment variables, and etc. And all of this is just kind of read-only material right now, and you really don't understand exactly what it means until you start searching through these types of services and the ports and the connections that are available. When I say you, I'm talking about I forget what the technical term is, but I'm talking about everybody in general. I'm not talking about you specifically as the user, although maybe this also applies to you. We don't really know what these things are. If you just read through it, it's almost like trying to learn how to swim by reading a book. So it doesn't really work that way. The best way to do it is actually to use this information in various exercises, which is what the whole purpose of TryHackMe is and what all these rooms are for. So in Windows memory management, a page is a piece of memory. The memory management system splits the physical memory into fixed size blocks known as pages. when a program needs to store data in memory, the system assigns it a certain number of pages. The system allows for efficient use of memory, as each program only uses the amount of memory that it actually needs, so it won't use anything more than it should. And that is commonly referred to as the baseline of memory that it's using, the baseline of processing power that it's using. The size of the page can vary, but it is 4 kilobytes on many operating systems. Pages are crucial for virtual memory, as they allow the operating system to page out less frequently used memory sections to the disk, freeing up physical memory for other tasks. So this is what we need to know as we continue with this room, because we're going to be referring back into pages in terms of measurements, or a term for measurement when we're talking about data sizes and so on and so forth. So the size of a page can vary, but it is 4 kilobytes on many operating systems. Just keep that in mind. And a page is a piece of memory. That's essentially what you need to know. Now, the RAM is the volatile memory that stores data and information about current programs, opening files, etc., being used or loaded into the CPU. It is volatile, meaning all the components in the RAM, the contents of the RAM, will be lost when the machine is powered off or rebooted. How memory is allocated: when we launch a program, the OS allocates a portion of the RAM to store the data and the code so that the program can function properly. This means any file or DLL, which is Dynamic Link Library. It's a library that contains code and data that can be used by more than one program at the same time. So in Windows, the COM-DLG32 whatever DLL, it performs common dialog box related functions. Each program can use that functionality that is contained inside that DLL to implement an open dialog box. It helps promote code reuse and efficient memory usage. So essentially means that this piece right here, the Dynamic Link Library, is a library that contains various sources of code and data that can be used by more than one program at the same time. Okay, so this is something that we refer to frequently when we're dealing with pen testing Windows or trying to catch hackers that have broken into Windows machines, because the DLL, the Dynamic Link Library, is something that is frequently manipulated by an attacker. And so in this context, in what we're talking about for volatile memory, the OS allocates a portion of the RAM, the random access memory, to store data and code so that the program can function properly. And this means any DLL or file that the program needs to function will also be loaded, or at least have a pointer to it, right? So these things are connected to each other. So the programs that have some type of RAM storage assigned to them are also using the DLL to function properly, meaning that Dynamic Link Library is open for most of these services that we saw at the top right here. There's some kind of Dynamic Link Library connection being made to all of those services over there. Now, a page file, so the PageFile.sys, is something that's used by Windows as an extension to the RAM. So think of it as a situation when a program needs more RAM, but the RAM capacity is full. So Microsoft effectively sorts this issue out by transferring less frequently used programs or data into the page file on the hard disk, on the hard drive on the computer. And this provides the RAM capacity needed for data being used actively. More details will be provided in the task that is going to come up. And so one of the big things that you probably have noticed, I don't know if you're big into computers or nerding out, things like that, but when somebody is a gamer, one of the big questions that comes up is, how much RAM do you have on your computer? And the RAM is directly correlated to the speed of the processing of the computer. The CPU is also very important. How many hertz of CPU processing power do you have? That's also very important. But the size of the CPU, the power of the CPU, as well as the size of the RAM, is directly correlated to how fast that computer can actually process and run services and run games, so on and so forth. So if you have a computer that has 8 gigabytes of RAM versus a computer that have 32 gigabytes of RAM, it's a completely different world, completely different types of machines. So for example, the computer that I'm on right now, the MacBook that I'm on right now, only has 8 gigabytes of RAM. And it's mostly because I don't really use it for really heavy load type work. I use it for screen recording and the types of recordings that we do. I use it for editing. But I don't need that much RAM on this computer, especially because the CPU is a fairly strong chip. It's one of the more recent chips that Apple released. However, my Windows computer that's in the other room has 32 gigabytes of RAM, and it has a monster CPU inside of it as well. And it works really quickly, and I use that to run Python programs simultaneously. I'll use that computer to run 6 or 7 programs, and mostly it's because it requires a lot of processing power to run multiple robust Python programs. I'll use it for gaming and so on and so forth. So it's very, very different when you have a computer that's running with 8 gigabytes of RAM and 32 gigabytes of RAM. But the whole concept here is that when the RAM is at full capacity, the computer is going to transfer the stuff that's not being used or is less frequently used. It'll transfer that into the PageFile.sys file, so that goes into the hard disk instead of the random access memory, because the random access memory is actively being used and the hard disk is kind of in the background, and if we need to use it, we can pull it from the hard disk and bring it into the RAM. But for the most part, it's going to sit inside of the hard disk, inside of this PageFile.sys. So it does not mean that if it's inside the PageFile.sys, it is no longer part of volatile memory. So that's something to keep in mind. Even though it's in the PageFile.sys and it's technically on the hard disk, it is still considered part of the RAM, or volatile memory, I should say. It's still considered part of volatile memory. So what happens to the memory when the system is hibernated? Imagine you're investigating a laptop for a crime scene the new intern has brought to the office for further investigation. He closed the laptop lid, turning it into hibernation mode. What do? Do you jeopardize the whole investigation? There's a way out. A Microsoft computer can turn the RAM content into a hibernation file called the Hiber file, or Hiberfil technically, placed on the disk, usually on the C drive. The purpose of the hibernation file is to resume the computer while preserving the state of the running programs. From a forensics point of view, accessing the hibernation file provides valuable information about the machine's state when it entered hibernation. More details we're going to be doing in task 7. Crash dumps are essentially for debugging purposes. Microsoft OS provides various options for dumping the crash files when a crash happens, so the computer just crashes and dies randomly. Some configurations stored the volatile data about the running processes, system configurations, etc. when a crash happens, which can be very useful from a forensics point of view. So these are the various sources of volatile data that we need to keep in mind as we progress through this specific room. And if you ever get a job in digital forensics, you need to also understand what these things are. So there's the page file, or the pages data. There's the actual random access memory RAM data. There's the dynamic link library data. And then there's, of course, the hibernation file, the hiberfile.sys, and of course, the crash dumps, or the crash files that happen. So what is the default page size in kilobytes for most operating systems? And that is 4. Let me make sure my keyboard doesn't die on me. Okay, very good. And what is the name of the hibernation file? And we have it right here. It is the hiberfil.sys. So let's do this. And then we have, did I not spell that right? Oh, HI. Oof, my gosh. So HI .sys, and then which file is considered as the extension of the RAM. And so which file is considered as the extension of the RAM, and that would be the PageFile.sys, which is the extension of the RAM right here. Whenever there's programs or data that we don't use all the time, it just gets transferred to the PageFile.sys that goes on the hard disk. So we have achieved managing volatile data overview. So let's look at the overview of PageFile. So let's get a better understanding of what this actually is. All right, as we've already established, the PageFile extends the physical memory, so the RAM, for the system. When the RAM gets full and can't hold any more data, like running processes, connections, Windows turns to the PageFile. So it transfers the less frequently used memory pages from the RAM to a designated storage place on the hard drive, which is the PageFile.sys, which is typically located inside of the root directory inside of the C drive. So it's a hidden file by default because you typically don't see it when you just run the dir directory or the dir command. So let's actually do that on the side right here so you can see what that looks like. Okay, so we are now inside of the command prompt inside of our Windows machine. And so if I go into the C drive and do a dir command, we'll see that these are the typical items that show up. But if I do a dir -a \a, it'll show up everything. And let me make sure I'm actually doing this, or /a. So if I do, let me clear this real quick, CLS. If I do a dir /a, excuse me, it'll show all of the other files that are typically hidden. And inside of that should be our PageFile.sys, which is right here, this file right here. And this is the file that also there's the Hibernation.sys. And these are the two files that we were talking about in reference to the hibernation mode, so on and so forth. So PageFile.sys is where those system functions or the services or connections that aren't typically used all the time, those things would be located in that regard. And then if you actually look at it from the Windows Explorer view, which is what this portion on the left side is here, if you go inside of the local C drive, you also don't see that PageFile.sys because it is a hidden file. And this is common. It's very, it's also inside of macOS and Linux as well. So those are things that you would have to run a different type of command to be able to see the hidden files. Now, the configuration related to this is inside of this registry location, which I'm not going to read this whole thing. You can just screenshot it if you want, or you can see what it is. But it's inside of the system hive. So if we go to the registry editor and actually navigate to this particular location, we can see that page files and the existing page file, so on and so forth, is all under memory management. And under memory management, you'll be able to find those specific hidden file registry locations. Now, extracting the data using the Forensic Toolkit Imager. So it can be used to extract the page file contents, which is available inside of our C drive. So if we actually open up the Access Data FTK Imager, we can navigate to that particular location and to be able to extract that data and look at it. So analyzing the data is probably the big piece right here, especially when you're doing forensics. You can use the strings utility to extract data because it's typically not legible with the naked eye, and you would have to use something like that to be able to pull the information that you need. So if we pull whatever data that we can find using the strings utility and transfer it to the PageFile strings text file, this is what it will look like. And then you'll start seeing a lot of jargon, and then there are certain random things like a Trojan downloader, for example. And that stuff would be useful when you're doing forensics, because why would somebody use a Trojan downloader, right? So all extracted strings will be stored in the PageFile strings txt on a desktop for review. As the system is or PageFile.sys is around 4 gigabytes, it will take some time to extract all the strings into it. And then you can do a bulk extractor command as well, where you do the bulk extractor command itself. Output would be the name of the file that you would get, and then you would create, or you would reference that specific location. The dot is referencing the current place that you're in inside of the file navigator. So for in this particular case, if you're inside of the C drive itself, if you do dot, that means you're referencing this location, and then you're just referencing that specific file itself, and then it will do an extraction of all of that, and it will put it inside of the output file for you, and the output folder shows the files extracted from that page file, which is what this whole thing looks like right here. So to save the time, the output folder has been placed on our desktop. We can see some files, etc., etc. Examining the URLs. This is massive. So this is the URL file that's over here. So we can see the URL histogram, and then there's also URL Microsoft Live. So a lot of different URLs that have been associated with it. And then, I mean, just from a glimpse real quick, you can see there's a lot of references to Blogspot, of course, and AttackMiter, Bitcoin. That might be an interesting little location. I don't know why they would do that. The Trojan may be related to that. But all of these things, I mean, there are better ways to analyze this instead of going line by line, but you can definitely see some interesting domains if you just analyze the URL file. So if we analyze the file, examine the document, to see if we can find any suspicious domains, I will just kind of pause right here to see if you can actually find anything before we go on with the rest of the notes. So in my mind, you know, this just seems to be funky. This seems to be funky. These various domains right here just seem to be really weird because they're not saying anything, and it's typically domains that are just random jargon type domains like this are not good domains. And then you also have the TF2 hack, and then there's various other domains that just at the first glance don't seem right. So one of the ones that they checked out over here in this particular case, it doesn't show us what it is because that's probably one of the answers that we're supposed to find. But if you take any of those domains and you actually go to VirusTotal, it'll tell you whether or not those domains are legitimate or they've been flagged by various antivirus analysis softwares or security appliances. So the page file can be a good source of information. Now follow the steps, extract and examine the page file and attached system, and answer the following questions. Would the registry hive contains the information, or which registry hive contains the information about the page file? So that's above us. We can go find that real quick. And then we're going to look at the domain histogram. Which domain associated with distributing malware has occurred 192 times? Defang the domain. And check the domain on VirusTotal. What's the verdict about the suspicious looking domain? So first and foremost, we want to find the registry hive that contains information about the page file. So that would be found at the very top right here. And that is found inside of the system hive. So let's go down here and paste that, or answer the question real quick. So that would be the system. And now we are going to run the exercises that we found right here to get the dump of that file and then go and look at it. I'm going to use this particular version right here, which is using the bulk extractor, because it'll give us a folder that has all of these other data inside of it. And what they want us to look through is the domain histogram, which is one of the locations right here. So we have the domain location right here. I think it's this one, or no, right here, the domain histogram. So we're going to use the bulk extractor, and from that we're going to look at the domain histogram. So let's go and do that. Okay, so they actually have done this for us. I completely missed that in the instructions when we were reading it. So it is located on the user's administrator desktop, and there's an output folder that actually has all of that data for us. And so the one that we're looking for is the domain histogram.txt, which is right here, and it is a massive file. So what I'm going to do, instead of navigating through this one by one, is I'm going to craft a simple command that will search through this entire data. It'll pull for us the number of unique domains that I've shown, and then from there it will show us how many times that specific domain showed up. So what we're looking for is all of the unique domains that are here, and then from there, how many times has it shown up. So let's see, if we look at it right here, actually I think it does say it at the top. I think these numbers are the reference to that specific domain, and I believe, from what I understand, I don't even need to run the command that I'm talking about, the command line. I think they actually did, yeah, it does say it. So it says number is etc., etc. So I think this is how many times Anglebug, for example, has shown up. So we don't need to run our search query right there. So the question is, what has shown up 192 times? So if I go over here and find the domain that's 192 right here, is 3z.nu, which definitely looks like a freaking bad domain. And so to defang it, typically they're going to tell us to use CyberChef to defang it. Search for N192 is already as one of our commands. So to defang a domain name, especially if it's a short one like this, it doesn't take much. So you just need to use the square brackets to wrap it around these dots so that it doesn't become clickable. That's essentially what it means to defang something. And when you're sending this, for example, in a report to your boss, and you say, hey, this is a domain that I found that's a shady domain, you just want to make sure that it's not clickable. That's what it means to defang a domain, or to defang an IP address. And in order to do that, you would just put the dot inside of the brackets. If it's an email address, you put the @ symbol inside of brackets. IP address, you put all the dots inside of brackets. Although in an IP address, because there's multiple dots, it's better to use CyberChef and just use the IP address defang option, and it'll just do it real quick for you. So there you go, 3z.nu. Now the question here is, check the domain on VirusTotal, and what is the verdict about this suspicious looking domain? So 3z.nu is what we're going to search for, and we're going to go to virustotal.com, and then we're going to go to URL, and we're going to do 3z.nu and press enter. And let's see here. So there we go. There it shows up on 14. Actually, it says 14 out of 96, and it's a medium 1. Let's see, but they're looking for a verdict, right? So is that the specific answer that we're looking for? So let's actually drag this right here. So we're looking for the verdict about the suspicious looking domain. So let's see. Okay, so assuming that the verdict means, what do they think it is? In this case, it would be malware. That's what I would say is the verdict on this domain. So let's try malware. I feel like that's the answer. Yeah, it is. Okay, so this specific domain name is associated with malware, and it's been detected by these various antivirus and security appliances. So that is it. So very useful tool right here. So if obviously we can pull a lot of data from PageFile.sys, and that was available on the C drive on the very root location of this computer, and it's available on every single Windows machine as well. And what you can do is you can use something like the bulk extractor tool, and you can output it into a giant folder like this, and then you get access to all of the data that can be pulled from that pagefile.sys file. So that is that. Now let's go look at the Hibernation file. And as we saw earlier, the hiberfile.sys file was right next to the pagefile.sys file when we ran the dir a command so that we can get all of the hidden files on our C folder, the root directory. It's very weird to say pagefile.sys file or hiberfile. I don't know, the file is in the name already, so it's like it's all very weird. Anyway, we can see that it's inside the C drive. The Hibernation file gives us a lot of information about the state of the memory. Some of that would be the containing of the memory snapshot of the RAM at the time of hibernation, information about user activities, running processes, network connections, recently opened files, so on and so forth. And the whole idea is for as soon as the computer is opened back up or it comes out of hibernation, that it just picks up where it left off, right? So that's the purpose of the Hibernation file, is to keep all of that stuff in its storage so that when the computer is just turned back on or comes out of hibernation, then it just picks up exactly where it left off. So we can use the FTK imager to look through it, which is inside of the hiberfile.sys again, and you can export it, which I think it probably is already done for us. It can take 4 to 5 minutes, so feel free to stretch your arms while you wait. Maybe we do have to do it. And then examining the Hibernation file looks like this. So if we look at, we'll use a handy forensics tool called the Hibernation Recon, and you look at process and then hiberfile.sys and provide the Hibernation file. It'll parse the file and view the raw image in a folder on the desktop as shown in the image below, which is what it looks like right here. And so the output path is going to be hibrec da 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 da, and this is essentially what it will look like. And so extracting information from it would be very interesting. Actually, I think this is looking at something else right here. So it'll create a folder on the desktop with uncompressed memory image. This process takes about 5 minutes. We can use Volatility to extract information from the uncompressed Hibernation file as shown below. So Volatility is the tool to extract information from this Hibernation file right here. So in this particular case, we're gonna extract information about the image using this particular command, which gives us the Hibernation recommendation file, which is this piece right here. That's the path to that file. And then you do windows info.info, which is a plugin that comes in with Volatility. And Volatility was a tool that we used in a lot of exercises in one of the previous videos, specific to the volatile data, extracting volatile data. And then we'll use the following command to extract information about the running processes during hibernation. And then exactly same thing, you're using Volatility, and then we're going to reference a different plugin for process list for Windows. and this is the plugin for just getting information about it. So Volatility works with plugins, essentially. That's what you need to know. And it has the Windows version that is exe, and then there's the Linux version that doesn't have exe. You're just saying vol, and then you run the rest of the commands exactly as it is right here. And it will give you data about the processes, for example, in this case. And then same thing with the process tree right here. Same thing. And then process tree is very important because it gives you the parent ID that is associated with all of these items, as well as a lot of other data. So just looking at the processes right here, you do see the PID and the parent PID as well. But in this particular case, you can see that there's a lot more information that's attached to it. And then we have the command line commands that will run, right? So you can again run the same volatile command, volatility command, and then use this specific plugin, and I'll give you the various command line commands that will run. And all of this data is very, very useful, and it can all be extracted from the Hibernation file. So what we're going to do is answer these questions right here. So at the time of hibernation, which network scanning tool was running? What is the PID associated with that tool? Examine the command lines executed on this host. Which data wiping tool was executed on the host? And what is the full path from which the data wiping tool was executed? So first, I'm going to see if we even have the file that we're looking for. We don't have that file, so I actually have to run this command right here to be able to extract the data from our hibernation file and then be able to get the rest of that data. So it's actually not a command that we ran. We were using the FTK imager, and we were going to extract those files, and then it says it takes about 4 to 5 minutes. So during those 4 to 5 minutes, I'm going to go grab another cup of coffee. So the first thing that I want to do, I'm just going to minimize this. I'm going to open up the FTK imager, and then from there, we're going to extract the data from the Hiber file. So, all right, just to make life easier, I went from this side view right here, and I just made the screen full screen so we can get access to this easier. The FTK imager is actually right at the bottom right here. This icon right here is the Access Data FTK imager. It is not inside of the Easy Tools folder, because at first I tried to find it inside here, but it was dragged or it was put as a shortcut for us in the bottom bar right there. So now what we want to do is we want to go ahead and pull this data right here from the file list and access it according to what we need. So first and foremost, we need to get inside of the evidence tree, we need to get our C drive image, and then from there we'll be able to access our hiberfile.sys. To be able to pull your partition into this, you need to click this first button right here where it says add into the evidence tree, and then when you click that, it takes you through essentially a wizard that allows you to choose any physical partition. In our example, there were 2 physical partitions, and I just chose the first one, which is physical drive 0, because that is the one that they chose in this instance right here. So when you click on physical drive 0, you open up this partition, and then when you click on no name, that's the status bar that you saw when I started talking. And so inside of that now, we can find the location of what we're looking for, which I believe is inside of the root folder, as we can see over here. So if I expand the root folder, we'll be able to see all of this other data right here. And what we're looking for inside of the root folder is the Hiber file. So let me see if I can find it down here inside of this data. So let's drag this down a little bit more, and we're looking for Hiber file. And there it is right there. So that is Hiber file, and you need to all just click on the root by itself, and then it'll show you the Hiber file. So I'm going to right click on this. I'm going to do export files, which is the very first option, and then we're just going to extract it to the administrator's desktop, right? That should be fine. So I'll just do administrator desktop right here, and then we'll extract it, and there you go. So you can see that it's already started, and it'll take 3 to 5 minutes. So we will come back to it when it is done. I will be right back. Okay, cool. So the extraction was completed, and now we're going to use this tool at the bottom right here, which is the Hibernation Recon, so that we can go ahead and get an actual folder out on our desktop for the Hiber file export that we just got. So I'm going to open this thing up. All right, just to give you a heads up, once you click on the Hibernation Recon and it loads, this portion is going to be blank. So what you have to do is you click on process Hiber file, and then you search for the location where the file was exported into. And when you do that, it doesn't show you anything. So it's as if I click on this and I just go into the desktop, and it's literally like this, just without this specific folder right here. So it only showed Easy Tools and Output, and this one wasn't here. And I just clicked OK, right? So I clicked Select, and then the very next prompt that came up was, where do you want to export it to? Which I chose the desktop, and then I clicked OK, and then it started this process right here. And then from here, it created this folder that you see right here, which is our Hibernation file. So from there, it's going to take however long it takes. Currently, it's on step 2 of 5, and it will probably take a few minutes based on what we got. So we're going to wait another 4 or 5 minutes to make sure that this is completed, and then we will come back and analyze the contents of that folder. So BRB. Okay, and now we have our Hiber file, so I'm going to close that out, and we're going to shrink this over here. And what we're going to do is we're going to use volatility for the rest of these items right here. And it seems like they're using the PowerShell prompt. So what we can do is I'm going to just go inside of my command prompt right here, and I've already converted it into PowerShell by just typing PowerShell, and then you can see that it goes from showing just C right here, and it has PS with the C in front of it. So now we are actually inside of PowerShell. So what we got to do is, first and foremost, we got to go into the location where the volatility is, and in this particular case, it seems to be the user's administrator location. So I'm just going to go back one, and let's clear the screen, and let's see if we do a dir, we can see that we have, do we have volatility here? It doesn't look like it's here, so let me see where it is. Okay, so I actually opened up a PowerShell window just to see if it would maybe show up here, and it still didn't show up here. So what I did is just ran the vol.exe command, and it loaded it, and it gave me a quick little help menu. So I do believe that it's already installed, and all we have to do is just call upon it. Sometimes I feel like we need to be inside of the actual directory that has the executable, but in this particular case, I think it's inside of our global path and environment path, so we don't need to. So what we can do is now just run the official command that has the full thing over here. So what we're gonna do is I'm gonna clear the screen, and we're gonna do vol.exe, and then the file is going to be the file that is inside of our users administrator desktop, and then it is let me see if I just do that, hiberfile.sys. That's definitely not it. So it needs to be the hibrec. Let's do that. There we go. That's it. And then what does the rest of it look like? Hibrec yada yada yada, and then active memory .bin. That seems to be the full thing. So I'm just actually going to open this, and yeah, there is an active memory .bin in here. So as long as you have the first few characters correctly, and then if you press tab, it'll fill in the rest of this for you. And then what we need is the final piece, which is the active memory .bin. Let's just confirm that, active memory.bin. Very good. So the first plugin that I'm going to use is the windows.info.info, and just make sure that the final I in info, in the second info, is capitalized. So I want to do this so I can see what the timestamps are, because the question that we had here is at what time, or not what time, at the time of hibernation. That's the question. At the time of hibernation, which network scanning tool was running? So that's what we need to find first and foremost. So we're going to run this and see what the answer to that is. Okay, so we have two timestamps of interest here. One of them is the system time right there, and then we have another one that is the timestamp, time date stamp, that's at the bottom. So 3/18/04, and then we have 6/05/13, and this is on 4/28/2024. This is on July 23rd. And I want to say, obviously, the system time being 4/28 is earlier than July 23rd, but it doesn't say what year of July 23rd this is. So it could be prior to this or it could be after, obviously, if we want to like really consider all the possibilities. So, but I'm just going to say 3/18/04 is the date, the time specifically that we're going to be concerned with. So the question now is, at the time of hibernation, which network scanning tool was running? So what we need to do is find the network scanning tool that is associated with the time of hibernation. And in this particular case, it could be the PS list that could do it for us, or it could be the PS tree. And I think that it might actually be the PS tree that gives us that information better. But I'm just going to run both of them and see what I can find. So let's see what we can find here. Okay, so here is the here's the output, and it is quite a lot of data. So what we're looking for specifically is a network scanning tool. And at the very bottom, I actually saw something that would immediately kind of trigger me to believe that it was a network scanning tool. But if we look at the very top right here, we can essentially see the name of the image, meaning the name of the specific process that's running. And there's a lot of stuff, and SVC host is like a big one, service host is a big one, OS query is another one of those things that shows up, DLL host, search UI, background task. All these things are not network scanners, as far as I know anyway. So what we can do is look for the ones that are outside of the very foundational services that are running. So SVC host, for example, is one of those foundational services. It's associated with a lot of different things. And the piece that we're looking for is something that actually has to do with some type of scanning, like network scanning. So Chrome itself, again, is nothing with that. Wireshark, for sure, has to do with network sniffing at the very least. And then we have dump cap. That could potentially be it. Conhost, dump cap again, PowerShell, shutdown CMD, disk wipe, PowerShell, conhost, etc., etc. So if I look at Wireshark and then try to look at the time, it's 6:04, which has to do with that specific time that we had at the very top again. So if we go over here, we do see that 6:05 specifically was the system time. So I think that is the time that we're most interested in, and it doesn't show us anything other than those two times. So Wireshark, I feel like it would be Wireshark. It's either Wireshark or dump cap, but I think if I were to be a betting man, I would say that it is indeed Wireshark. And if we actually look at dump cap right here as well, you can see that the PID that is the parent of dump cap is Wireshark. So the PID for Wireshark is 5604. The parent ID for dump cap is 5604, which means that dump cap actually belongs to Wireshark. And it was running on multiple occasions, 604, 604 right here, 605 right here, shutdown being the last piece right there. So we're going to say that Wireshark is the item that we're looking for. If not Wireshark, it would be dump cap. So Wireshark, let's run that. There you go. That is indeed the answer. Very good. So what is the process ID associated with the network scanning tool, which we already found as well over here? So where was it? Wireshark, the process ID is 5604. So let's type that in here. Whoops, 5604. There we go. And then examine the command line executed on this host. Which data wiping tool was executed on the host? So we also have the command line values that are over here as well. And it shows you the command line that was ran for each one of these things. And then you can see just diskwipe.exes right there, but it's also under the images as well. So diskwipe.exe would be my guess in this particular case. So let's run that. And that is indeed the answer. And so what is the full path from which the data wiping tool was executed? And that is all over here as well. So this, I gotta see if I can copy this whole thing. Let's see if we could do, nope, we can't do right click. So we'll do that and we'll do Control C. Let me try that one more time. Control C. There we go. And it did indeed copy it. So perfect. We got it. So Wireshark was the answer, and we found I found most of this information by just running the PS tree plugin. I didn't have to run the command line plugin because the PS tree plugin actually gives you the command line values. It's a very useful plugin that comes with Volatility. and we have all of that data over here. And if you just look at the stuff at the very top right here, it gives you the column names associated with everything. And then there is one that is associated with command line. I literally just saw it too. That's so annoying. But I did see command line being a part of that whole piece. So, oh, there we go, CMD. So CMD would be the command that's associated with it. And so we did find that as well. So very good. So we found all the information that we needed for the hibernation file. And now we can move on to the crash dump. Okay, so I don't know how long you've had a computer, but if you've had a computer for at least a year and you've used it frequently, you'll probably notice that a computer can crash. If you use too many services, if you do something that you probably shouldn't, if you try to open up too many programs or applications at the same time, the computer may overload and it may crash. And thankfully, it hasn't happened to me in a very long time because I got some computers that are fairly powerful and I've learned how to not overload my computer. But you can have a crash for a variety of reasons. One of the big ones is if you don't update your system when there's a system update required. More often than not, sometimes it'll just crash, and then upon reboot, it'll ask to update the system. So crash dump is something that happens fairly commonly. And when a system crashes in Microsoft specifically, it generates a crash report containing information related to the crash for debugging. And usually when that happens, you'll get a prompt as soon as the computer starts that says, hey, unexpected reboot happened or unexpected shutoff happened. Can we send this report to Microsoft? And that's what that debugging report is. And I would recommend you do send those things out. So once the system goes into the crash, the OS copies the data into the paging file and moves to the crash dump after the system is turned on. The OS provides different configuration options to handle system failure. So you do this. You go to the control panel, system security, system, advanced system properties, and settings. And then from there, you'll be able to find the information for startup and recovery settings, and you can see the configuration options that look like this. When you click on startup recovery, you can see the types of dumps that can be created, right? Automatic memory dump, kernel memory dump, a small one, a complete memory dump, which is probably a massive file, automatic memory, etc., etc. And it seems to be that the previous selection was the automatic memory dump, which probably includes, I would say, all the important stuff that were maybe running at the time. So each crash dump option is explained below, and it's right here. I am not going to read through all of this for you. We will probably reference it through the rest of the questions as we have over here. But you can also just pause this and read it if you want to, or let's see if this is a free room. No, this is a subscriber only room. So you do need to get access to a paid membership to be able to do this, but you can just pause it and read through it if you want to. So from here, we'll be able to pull the rest of the questions that we need inside of this specific task. The settings about the crash dump can be viewed inside of our registry hives at this particular path, which would be under crash control, and then you can see the crash dump that's been enabled, and then you can mess around with those settings if you need to. The value of the field crash dump enabled is set to 3. That represents a small memory dump, selecting in the settings. So if we were to look at these options right here, I guess small memory dump in this particular case is associated with the value of 3. And more details about this can be found in the official documentation as shown below right here. So registry values for startup and recovery. This is just a screenshot of the documentation for Microsoft, specifically the registry value for startup and recovery. And then you can see it right here, right? So the value of 3 is associated with small memory dump, 7 is associated with automatic, 2 would be kernel, 1 would be complete, and 0 would be no memory dump. So the reliability monitor is something that can be checked to see how many times the system has crashed, and then look for the crash dump files to extract information that could aid your investigation. So how many times did this thing crash? Searching for the monitor option in the control panel, it'll show you exactly when and how many times the system was in trouble and it crashed. And this is actually very useful as well. So control panel, system security, security maintenance, reliability monitor, and it'll show you how many times this thing has actually crashed. And then we get some more detailed information about it. So for example, a critical event, Windows was not properly something. In this particular case, Windows stopped working is another one. And then successful Windows update is one of the reasons why it was actually crashed and restarted. So these are the various instances why this particular machine was restarted. So during the investigation, if we find a suspicious process ruining on the host, I think they were supposed to say running on the host. So if you find a suspicious process running on the host, we can also create the crash dump of the active process by opening the task manager, right-clicking on the process, and making the manual dump as shown below. So you open up task manager, you find the process itself, so PowerShell in this example, and then you create a dump file from that, and then you'll see what you can get from there. So go to the path where the crash dump was stored, save it to the desktop for further investigation. And then we have our questions associated with this particular task. All right, so question 1 is, what is the value of crash dump enabled field in the registry? So we got to go to the registry, examine the reliability monitor chart. What is the report ID of the last dump? How many times has the system reported critical events in the past? And what is the default path set for placing the crash dump in the settings? So all of this is going to be inside of our settings for the most part, I think. I think so, yeah, actually. So first and foremost, we're going to go to the registry, and then after the registry, we're going to go into the settings. So I'm going to minimize our PowerShell instance here, and I'm going to go to the registry editor. And so one of the key little tricks about the registry editor is that you can go to the path by simply typing it. So if I actually copy this and take it over here and just place it after computer, I can essentially skip to that part of the registry like so. And then we press enter and it'll take us exactly to it, just like that. So perfect. So we're going to do crash control, and then what we want is the crash dump enabled. And what we're looking for is the value of it. So let me open this back up inside of the full screen mode real quick. And what we want is the value of this piece right here. So we're gonna make that a little bit bigger. Very good. And I can double click that and it'll give us the value data, which is 1 in this case. So we're gonna go and answer the first question, which is 1. The next one is going to be examine the reliability monitor. What is the report ID of the last crash dump? So for that, we're actually going to go into settings, and the path for the reliability monitor was control panel, system security, security maintenance, and then reliability monitor. So let's close this out. Gonna open this up, and here we are. So control panel, system security, security maintenance. And then under maintenance, we have view reliability monitor. This is what it originally looked like. So they weren't brought down, opened up. So we click on maintenance and then do reliability monitor. And then it'll open this thing up for us. And so what we're trying to find, I think I still have to let it load for an instance here. But the question is, examine the monitor chart. What is the report ID of the last crash dump? So let's see. Okay, so as we're looking at this, there's literally no data here. And so when I clicked on the hint, we were actually given an update where it says the reliability monitor is no longer showing the expected crash dump. We're working on the fix. Here is the answer, and that's our answer. So it's kind of anticlimactic, but whatever. We got the answer for this. Now it says how many times the system has reported critical events in the past. So that we would find, I believe, in the, I think the same thing, honestly, but let me just double check and make sure. Okay, so since we don't have any data over here, the only other place that we can really track that down would be the event viewer that is inside of Windows. And event viewer shows us a bunch of data, including potentially critical events. So what we want is to find the event ID that we would need to look for that has to do with critical events. So let's do Google search. Okay, so it says there are several events that can indicate critical events, including 4624, 4625, 756. There's a lot of stuff right here. So user has successfully logged onto a computer, so on and so forth. So I think what we're not getting is that it has to do with the system reboot or system crash. So let me fix that. And this is what we got. So event ID 41, the system has rebooted without cleanly, etc., etc. So I think it's event ID 41 that has to do with the system being rebooted or crashed. So what we're going to do is we're going to now search for those events. Let me make this maximized a little bit. So we're looking for critical events that have to do with the system crashing. Okay, so I created a custom view on the side right here. This window opens up. You want all of the, I just highlighted all the events, and by the event logs I chose the ones that were actually available, so Windows logs and application logs, and then right here for event ID 41. So let's see what we get. So it says filter a custom view. You're creating references more than 10 event logs. The result might perform poorly and consume a large amount of memory or process time. Do you want to continue? I'm going to say yeah, and let's see what I can find here. Okay, so event viewer cannot open the event log or system view. Verify that the service is running or query is too long. So what we want to do is make it a little bit less robust as far as the results are concerned. So let me see what I can do to make that a little bit shorter of a result list. Okay, so the path that I took to actually find these results so I'll share with you what I did, but the answer that I got is not the correct answer. And I think maybe it's because the specific machine isn't loading properly, like they said for the last question. And that might be the reason why we're not getting the numbers that we're supposed to get. But if you go to create a custom view right here, and I just selected all of these, but that part doesn't really matter because it actually just shows you everything. But we're specifically looking for critical events, and then the event logs themselves are going to be Windows logs in this particular case, and then we do an event ID of 41, and then the new view is just a custom event that's created, that's available on the site on the custom views. And then it gives you 3 results right here, and they're all critical level. And then when you open it, it actually shows you system has rebooted without cleanly shutting down. This could be caused if the system stopped responding, etc. And so it's under kernel power, event ID 41. It is a critical level, and that is what I was able to find. Now, what you can do in this particular case is you can look for a variety of different event IDs to see if something else shows up. So we got 3 under this particular one. So if I go back and search for the last piece that I found again to see without the system crash one. So if we went to just search for this general thing, and then we see all these pieces right here. So user successfully logged on to a computer, attempt made to log on, unknown user, log off process completed for user. These are all critical events that are shown up, but the only one that's relevant to the system crashing and the one that we're looking for is system ID 41. So in this, or event ID 41, in this particular case, the answer that we got was 3. So there's 3 events. But based on the documentation for TryHackMe, the answer is actually 7. Meaning that there's supposed to be something else, or at least 4 other items that show under the critical events. So how many times the system has reported critical events in the past. And we could potentially go and try to search for critical events as well. So what I'm going to do is I'm going to actually do a search for critical events and see if I can find anything else under the level of that critical event. So I'll try to create something else real quick and see what I can find. Yeah, so even searching for critical events just by themselves with no event ID, we only got 3 results that showed up. I'm going to search for critical events under the application and service logs now, and that gives me an error message because it's not loading. It's saying that there's too many of them. So we did everything under Windows logs and we only got 3. Application and service logs, there's too many of them. So maybe if we go through this particular situation where we're looking for the types of events that show up, right? So you have critical events in the last however long, nothing has shown up. So if I try to view all of the critical events, it only shows me for the last 7 days here. And these are all the results that are available for the last 7 days. So I did any range when I created that custom view to see if it's any time, last 24 hours, 7 days, last 30 days. So let's do last 30 days and see, maybe we'll get something different. And we also got an error for that as well. So the challenge seems to be in this case that the machine isn't processing the requests that we're making appropriately, and I may be, you know, out of my depth. I may not know what I'm doing, or there's something I might be missing. But as far as I know, we should be able to find it by searching for either critical events or the event ID of 41, which is the system crashing and rebooting without properly logging off, which is essentially the whole concept here. Like the crash dump is what we're supposed to be searching for in this case anyways. So that's the challenge in this particular case, is that for the context of this search that we're doing, I can't find it. So if you do find something different, and whatever approach you took, I would really appreciate it if you could drop it in the comments, so that I myself, as well as all of our other viewers and students, can also find out what it is that you did, so that they can come to the right answer. But I found this answer from the documentation. And the last question that we're looking for here is the default path for the crash dump in the settings. So we're going to go back into our control panel and try to find that information real quick. And just for your information, so you go to control panel, system security, system, and then you have advanced system settings on the left hand side right here, and it opens up this dialog box for you. And then what you want to do is go into startup recovery settings, and inside of the startup recovery settings we have this as our path for the dump file. So I'm going to copy this, and we're going to go here and we're going to paste that, and hopefully that'll be the right answer. And that is indeed the right answer. Okay, great. So we got everything that we needed for the crash dump overview. So now moving on into this last portion, which is analyzing the crash dump. Okay, so the Windows debugger is a common debugger tool that's provided by Windows and Microsoft. It's used to analyze and debug Windows applications, crash dumps, drivers, and a lot of other things that can be done with it. What we're going to do is we're going to use it to analyze and extract volatile data from the crash dump that we got from the previous task, which is going to be stored at this particular path. So this is what we're looking for that dump file, right? And it says go to the path where the crash dumps are stored and save it to the desktop for further investigation. And so what we're going to do is that path, we can literally use that exact path to inside of the file viewer, or the Windows Explorer, I guess I should say, to open up the dump file and to be able to get access to what we need. And so this is what it's going to look like when you actually open it up. It's very similar to a command line, and then there's a debug that's running, so it'll run that for you. And then you can use various commands to interact with it. So using the command analyze v to get the dump file analyzed by the debugger, the v option provides verbose output as it normally does with any kind of command line tool. It'll do an automated analysis of the crash dump and provide a summary of the problem. And you just put that right here in the command line portion right there. And depending on the size, we can get information about the application that actually caused the crash. For example, the symbol name, the module name, the image location, the command variety of other data that comes from it. You can also get the time of the crash by looking for exclamation time, and you can input that into it as shown below, and I'll give you the results. And of course, system information, so sysinfo, and you get information like CPU info, machine ID, to display information related to the machine and the CPU as shown below. So sysinfo right here, and then you can also get sysinfo machine ID, etc., sysinfo CPU info, so on and so forth. So you would input that into the command, and then you can get the VM information, so the virtual machine information as well. And it's, again, just run the command, and it gives you a lot of information about the processes that are running on the machine, as you can see right here. T-list is the time of hibernation, so it displays all the running processes on the system at the time of the hibernation, and it can be useful in finding out what processes were running on the system and if any of them were suspicious before the system actually crashed. So T-list, so .tlist, just to keep that in mind, .tlist, it's not an exclamation, and then exclamation process 00 to extract information about running processes, parent processes, sessions ID, so on and so forth. So process 00, I would assume that these are the ID numbers. So if you do 00, it should show you everything that's available over there. And then the environment block is a data structure maintained by the OS that contains information about the Windows environment and the state of the process, including configuration, environment, variables, etc. So PEB, process environment block, is what we're searching for with the exclamation to get information about the configuration as shown below. So the client name, the computer name, home path of the users, OS type, the path to the OS, or the variety of different paths that we have. These would be the environment paths, for example. So since we only have a small crash file, it's going to go and show information about the process that caused the crash, review the second crash report, and extract the information from it using WinDB. In this task, we analyzed and examined the memory crash dump on our investigating machine. The memory dump we analyzed was a complete memory dump generated by the system when it crashed. It contained information about system configuration, running processes, etc. So which application was responsible for the first crash? What is the process ID associated with a suspicious looking process called evil.exe? Which command can be used to find the exact time of the crash? And of the following variables PEB contains in a secret flag, what is the value of the flag? So which can be used to find the exact time of the crash. That's the command that we're looking for. And so that was actually available here. So we can get that real quick. That would be the time command. So exclamation time to find that. So we can just do that real quick. And that should be it. So the next few, we got to actually do some research. So which application was responsible for the first crash? So let's zoom out here and let's go find that. Okay, so the first thing that we want to do is we want to open up the Windows debugger, and you can search for it. I think it's also actually this icon that's at the bottom right here is the Windows debugger on this particular machine, but you could literally just open up the search and do WinDBG. It is case sensitive, so it didn't show up for me when I just did lowercase dbg, so you would have to do, capital Win and etc. etc. So it brings you here, and you're going to go start debugging, open dump file, browse. And then inside of the browse, I would just paste the path of the dump file, which is memory.dmp at the system root, and then press open, and that will bring us the actual open dump file. So let's get that. Or I guess I'll press enter first, and then it'll open it for me, and there it is. So now we have this. So let me close the first window, and we have the window. Oh, whoops, I closed the wrong window. So let's try that one more time. Okay, so here we go. So what we're gonna do, the first command that we can put at the bottom right here was analyze v. So let's see what we can get here. Okay, that took a few minutes, maybe 3 or 4 minutes. We have a module name that's associated with it. It's called myfault, and then we have myfault.sys, which is the image name for it. And just to show you what happened, essentially after I typed analyze v, all of these things happened. So there's a lot of data that was pulled up, and the command is actually exclamation analyze v, and then I started the debugging, and then it went through all these various points, and it took a few minutes before it happened. Wow, I can't believe I just zoomed out. How did I zoom out of all of that? I zoomed out. It was like a super zoom out right here. But myfault.sys or myfault by itself, I believe that's the answer. So let's try that real quick. Cool. Which application was responsible for the crash? It is myfault. Now, what is the process ID associated with a suspicious looking process called evil.exe? So that's what we were trying to find, and we're going to be able to find that with the process details command, I believe. Process environment block, and yeah, so process details is what we're looking for versus. Yes, correct. We can also, I think, find it with the VM command right here as well, because it does show the process names right here with their process IDs that are associated with it as well. So we could do either of those two, and myfault is actually right here as well. So myfault was showing up over there. So maybe I don't need to run the other command and wait for the results. So let's see if we can find the evil.exe. It's not on this list right here. And let's see if we can find it on this list. It is not on this list either. Let's see if we can find it on this list. It's not here either. So I gotta actually run the command to try to find it. So I'm just gonna run the exclamation VM to see if I can find the information that we're looking for. Okay, so there we go. If you press Control plus or Control minus, it'll zoom in or zoom out for you. And at the very, very bottom, so if you scroll all the way down, it's the first item at the top right here where it says evil.exe 1970 would be the PID for it. Let's see if we can do a find command where we can search through this data right here. I can actually do Control F and do evil exe, and it will show me the search that it finds, which is again 1970. So evil exe is 1970. So let's run that. And last but not least, one of the variables in PEB contains a secret flag. What is the value of the flag? So we got to run PEB. So it's going to be exclamation. Okay, and there we go. And we found all of the data from here as well. So now what we're looking for is something that resembles a flag. And these are all variables that are assigned to our environment. So just kind of let's zoom in here and see if we can find the flag. Oh, there we go. It's literally the flag variable right here. And it is THM is fun to learn at THM. And to be honest with you, it is fun to learn at THM. So let's copy that and let's go over here and paste it. Boom. There you go. Just like that. We are officially done with our analyzing of the crash dump. All right, so in conclusion, let's zoom in here a little bit. We have the Hibernation File sys, which is created when the system goes into hibernation mode. You have the hiberfile.sys that is a compressed copy of what is on the RAM, and it's all the processes that were running before the crash, timestamp, etc., etc. When the RAM capacity is full, the copy of the Windows all right, so in conclusion, we have some bullet points here. So we have the hiberfile.sys, which is created when the system goes into hibernation mode. And it's a compressed copy of what was on the RAM, what was running on the RAM. So it could be timestamps of things, it could be the services that were running, the processes that were running. All of that is going to be on the hiberfile.sys. And then we have when the RAM is full and there are too many things going on, all of the stuff that's not being used as frequently or less frequently, that volatile data is going to go into the PageFile.sys. And this is done to provide extra memory so that the RAM can actually function and run properly. Crash files are created for troubleshooting, and we saw where our crash file was stored, the path that we got for it. And then we can provide information about running processes, system configurations, and a lot of other stuff from that crash file. And all of that can be found at the path of that memory dump file that we found. And then you can go check to see across the registry location what type of data is being backed up to the crash file whenever there is an actual crash inevitably. And we found out what the event ID was that was associated with reboots on the crash. And in our particular case, I think it wasn't showing the right information because as we saw from that one hint, the system wasn't updating properly, so we weren't able to find the information, so on and so forth. But this is really, really good data that you can find about volatile data on a computer when something goes down, and you want to make sure that you retrieve the information that is very, very useful. For example, when the computer crashes, right? Because volatile data gets wiped when the computer crashes, or if it turns off, so on and so forth, and you want to be able to find that information. And you can technically find some of the data about the running processes, about the things that go into saved when the computer goes into hibernation, or when the computer is crashed, because the hacker might be really smart and they could make the computer crash. So you will find information about all of that stuff from these various backup files or these dump files, and it's very, very useful. So there's a lot of other stuff that we can be learning here, which is under the user account forensics, user activity analysis, Windows applications forensics, and of course the secret recipe lab. And there's still so many other rooms that I was supposed to do based on the last volatility room that we did, and I still haven't even finished those. So I keep opening up new tabs here to see which other ones that I'm supposed to do, and it just keeps getting more and more. There's more homework for us to do. So for now, though, we're officially completing and have done the analyzing volatile memory room. That was just one of those external or kind of like standalone rooms that is inside of TryHackMe. And just to kind of show you what all of the extra rooms are that just came from the lab that we did right now, as well as the last one that we did on volatility, we have the Windows user account forensics, we have the user activity analysis, we have and my computer is literally kind of slowing down. This is what I was talking about RAM earlier. Windows application forensics, secret recipe, which is a challenge, the incident response difficulties and challenges, iOS forensics, and of course Windows applications forensics. So all of these things just came from this video that we just did and the last one that I did on volatility. And I'm going to do all of these. I'm just going to leave all these labs open, these tabs open, just so I don't forget them. And it's a really big list, apparently. I could probably just save the links as well. I think I'm going to do that, actually. I'm going to just save the links inside of my little note document and then just visit these one by one so I don't take up all of my RAM and my processing power, because Google Chrome is taking up a lot of processing power now. So that being said, we are officially wrapped with the video for today. Alright, if you found this video useful, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And of course, go check out everything else that we got on the channel, because we do got a lot of great stuff, and there's still more stuff that's coming out. They're all scheduled already, and there's just going to be more stuff as I make more videos, and I'm in the content season right now, so I'm going to be making a lot of great stuff that's going to be coming out. And we already started the Cybersecurity 101 training series as well, so there's a lot of great stuff that's available. So if you have not done so already, go check out what's already on the channel, and of course, like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And actually go to the comment section and drop a comment, because I am very responsive to the comments that come in. I do respond to everybody that drops a comment. And then if you have a really good question, I will make a video out of your question. And Darnell was the guy that asked for the Cybersecurity 101, like the beginner training series. So we have an actual playlist that has been inspired by a comment that came in through the comment section in the community. So if you have not done so already, definitely subscribe, like, comment, all that good stuff, but definitely ask your questions, because you'll be getting your question answered, but you'll probably also help everybody else in the community too. So it'll be a really, really cool thing to hear from you, and hopefully I'll be able to help you out as well. And of course, make sure you check out Hackaholics Anonymous membership community. It is the premier YouTube community for security analysts and hackers. And this is something that I'm very, very passionate about, and I put a lot of time and energy into it on the daily. I just want to make sure that you guys get all the value that you possibly can from this community. We have 4 tiers. The supporter tier just recently got access to their own Discord server, so you'll get access to me directly, as well as everybody else that's in our advanced tiers. The advanced tiers get Python automations and digital downloads and exclusive content, so on and so forth. But just for $4.99, you'll get access to the supporter tier, which gives you your own Discord server to communicate with me and all of the advanced members. And if you want to check out what else is available, either watch the 14-minute video or click on this read more button right here and look at the description, because everything is outlined in the description for it. So if you have not checked out Hackaholics Anonymous, I highly recommend that you do. I am I'm determined, maybe destined, maybe that was like a Freudian slip, but I am determined to make it the best community for hackers and security professionals that exists on YouTube, and I think you'll very much like the value that you get from it. So definitely check it out if you haven't done so already. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next room. Later.